So in our previous video, we were talking about functions and the vertical line test and how to determine if a graph is a function or not, and domain and range and all those things. And so in this video, we're going to talk about the equations. And we call it expressions because really the part we're focusing on is this part on the right side of the equation. So one thing that we can think about when we think about if it's a function or not, if the equation can be written in the form y equals something, okay, so y equals something, then the expression is a function. And if you had access to a graphing calculator in high school, you know that when you graph a line, graph anything on your calculator, there's a button that you push that says y equals. Well, the graphing calculators do not graph anything that's not a function. And so when you hit that y equals, what you put in is your function. So in this case, like the 2x minus 5, that's the function part of it. Okay? And so when we talk about the expressions, well, yeah, it is an equation because there's an equal sign. We're really focusing on the 2x minus 5 part of that. So just kind of be aware of that as we work through some of these. So first thing we're going to do is identify if it's a function or not. And in this first example, it is a function. And we know that again because it is y equals. And then we want to talk about the domain. And so the domain is what we put in. It's our x value. And if you notice back where I gave you the definition, there it is, we said that it's the x values, but we said it's what you put in. And the reason we want to talk about it being what you put in is because we want to think about a function sort of like a machine. Okay? If we were to take a machine, this f of x is our function notation. We'll talk about that later. In a function, what happens is you take some value, you put it in, you do some stuff to it. You may add, subtract, multiply, divide, square it, cube it, take a square root. You can do a lot of operations to that value. So you take the x, you put it in, you do something to it, and then it spits out our y value. And so we say that the x value is what you can put in, the y value, the range value being what you can get out. And so as we look at these expressions and think about, is this a function, is this not a function, what's the domain, what's the range, we want to think about it from that machine standpoint. So on this one that we have here, the y equals 2x minus 5, our x value is what we put in. So the question becomes, what numbers can I put in for x? So think about that. Can I put in 0 for x? Well, sure. If I put in 0, then I'm supposed to multiply it by 2, because again, think about it. You're putting in the number here for x. You multiply it by 2 and then you subtract 5. Well, I can do that to 0, right? Can I do that to any positive number? Pick your favorite number. Can you do that? Can you multiply by 2 and subtract 5? Well, you should be thinking, yes, I can. Take any negative numbers. Can we do that? Can we multiply a negative number by 2 and can we subtract 5 from it? Sure, absolutely. And so what we see then is that no matter what number we choose, we always can take some number and multiply it by 2 and subtract 5. And so our domain then, what we can put in, has to be all real numbers. And we write that as anything from negative infinity to positive infinity. So, not too bad. Well, the range then is what you can get out. And I want to caution you and make you understand that you have to be able to think. We talk about all the time that the purpose of a math class in college is to teach you to think. Well, this is one of those places where that really has to happen. Because there's not a way to say, oh, well, the range is this every single time. You've got to think about, well, when I put these domain values in, these any number for x, what are possibilities that I can get out for y? And so you may want to try some numbers. You know, if you put in 0 for x, for example, 0 times 2 is 0, and 0 minus 5 is negative 5. You could get negative 5 for y. Could you get 0? Well, sure, if you put in the right number for x, and it could be a fraction or a decimal, if you put in the right number for x and you multiply it by 2 and you subtract 5, you could get 0. Or if you were to put in If you wanted y to be a positive number, 10,000, well, sure, if you put in the right number for x, multiply it by 2, and subtract 5, you can get 10,000. Or you can get negative 10,000 or negative 10 million, or pick your number. And what you see is that the range value also could be all real numbers. Now, that's not always the case with every one of these, but it is the case here. And so those are the three things I'm looking for: function or not, domain, and range. But if you want to have a little sketch to look at of a graph, this graph would look, and again, this is strictly a sketch, would look something like that. Well, as you see, as we've talked about previously, this thing is going to the right forever and it's going left forever. And so it makes sense, hopefully, that our domain would be all real numbers. Go left forever, right forever. It also goes up forever and it goes down forever. And so hopefully the y value, the range value, makes sense that it also could be all real numbers. And so sometimes that sketch is going to be helpful, especially later on as we talk about how to graph with any function. It's going to be easy for you to look at that and say, oh, well, I could graph this by making a table and looking at some points to see what that graph looks like. So if we look at the next one, again, we want to know if it's a function or not. Again, it is y equals, and so that tells us that it has to be a function. And there will be times when you can't solve for y and make it be y equals something that is a function. So just kind of be aware of that. That doesn't always happen, but most of the time it is going to happen. Now, domain, numbers that we can put in. So think about, well, what am I supposed to do to a number if I put it in for x? If I told you x is 2, what are you supposed to do to it? Well, hopefully you're saying, well, I'd square it and I would add 3. Well, that's exactly right. If I tell you that x is 2, you're going to put 2 in for x, you're going to square that, you're going to add 3 to it, and you're going to get your value for y. So the question becomes, when we talk about the domain, what numbers can I do that to? What numbers can I square? Well, I can square positive numbers. I can square 0. I can square negative numbers. And with all of those, I can then add 3. And so, again, when we see our domain is everything from negative infinity to positive infinity. But where this becomes a little bit more of an issue is with the range value. Because with the range value, it's not going to be all real numbers. Because think about what happens when you put any value in for x and you square it. What happens when you square a number? So again, be thinking about this yourself. Hopefully you know that when you square a number, it becomes positive. If you were to square negative 2, for example, negative 2 times negative 2 is positive 4. And so when I put a number in for x and I square it, that's becoming positive. This value becomes positive if I put in a positive or a negative number or 0. Obviously, it could be 0. But then what do I do with that? Well, I'll take that and I add 3 to it. And so when we think about this range value, we think about, well, what are the possibilities that I could get out for my range value, my y value? Well, the smallest number this x squared value could become is 0, right? Because if I square 0, so let me just kind of work that out for you here. If you put in 0 and you square it, and then you add 3, well, 0 squared is 0, and 0 plus 3 is 3. So y could be 3. But y can't be anything smaller than that, because there's no way that this value is ever less than 0. Could it be bigger than that? Well, sure. If I take 1, for example, and I square 1, I get 1, and 1 plus 3 is 4. And so that number could be bigger, but it can't be anything smaller. And so the range value, again, you have to think. You have to play around with numbers, think about what can I put in. You'll see that the range is everything from 3 to infinity. Now, again, if it helps you to look at a sketch, well, the sketch of this graph would look something like this. It's a parabola shape. And it should make sense based off that graph. This thing goes left forever and right forever. And so the domains are real numbers. But the range value only goes down to 3 and then it goes up. And so it's everything from 3 to positive infinity. And so that's where that range value is coming from. Now, again, I know there's probably questions. I don't know what questions you have until you ask. So I definitely encourage you that as you watch through this, we're going to do a couple more, but if you say, well, I just don't get it, I don't understand, that's when you need to make sure you email me. Okay, I cannot stress that enough. All right, so let's look at each of these. So on this next one, this one is in the form x equals, not y equals, but x equals. And there's nothing we can do to get this y by itself, to make it be y equals something, right? And so because it can't be put in that form y equals something, this one is not a function. Now, as we think about domain and range, domain is still our x value, range is still our y value. However, if I told you that x is 2, well, you're not easily going to be able to tell me what y is. However, if I told you y is 2, well, then you can tell me the value of x, because the absolute value of 2 is 2. Or if I were to tell you that y is negative 5, we'd say, well, the absolute value of negative 5 is positive 5, so x is 5. And so really, because it's not a function, we want to think about finding domain and range in the opposite way, with the y being what we're putting in, the x being what we get out. Because in this case, we would put numbers in for the y value. And then we would take the absolute value, and that would give us the x. So we want to think about what are possibilities that we can get out for the y. What numbers can we put in for y and take the absolute value of? Well, you can take the absolute value of 0 and anything positive, anything negative. And so that range value, that y value, has to be all real numbers. Anything from negative infinity to positive infinity. So when we put those numbers in, what are possibilities we can get out for x? Well, we know that when we take an absolute value against a distance from 0, and so that tells us that a distance has to be positive or it could be 0. And so our domain then could be 0, or it could be anything positive, but it cannot be negative. And so our domain in this case is 0 to infinity. Now, if you look at the sketch of this one, this graph looks like this. And from a domain and range standpoint, it is going from 0 to the right forever to infinity, which makes sense, hopefully, with our domain. And this also, as it goes right, is going up and down forever. And so our range value is everything from negative infinity up to positive infinity. So hopefully that makes some pretty good sense, especially when you see the graph. Again, if you have questions, definitely email me and let me know, because I know there's going to be questions about that probably. On the next one, kind of the same deal as what we've talked about. We want to know if it's a function or not. It is in the form y equals, so it is absolutely a function. Now, domain and range. For the domain, again, it's the x values. Well, what do we do when we put a number in for x? Well, we're going to add 2 to it, and then we're going to take 3 and divide by that number. And you may remember from one of our sections, chapter 1, you cannot have a 0 in the denominator because you can't divide by 0, right? So if this x plus 2, whatever number we put in, becomes 0, well, then we have a problem, because we can't say 3 divided by 0. And so there's only one number x can't be, and it's going to be whatever makes this denominator be 0. In this case, it would be negative 2, because if I put negative 2 in for x, negative 2 plus 2 is 0. So our domain could be anything else. We can add 2 to any number, we just can't divide by 0. And so our interval notation for that domain then is everything from negative infinity up to 2, not including 2, so we use parentheses, in union with everything from 2 to positive infinity. So remember that union just means it's everything on both sides of 2 all the way up to it, not actually using the 2. And then our range value, and this is something that if we were in class together, I probably would ask you to try to come up with what the range value can't be. And would probably wait and give you some time to kind of think about that and process that. But in this setting, I'm just going to go ahead and tell you the range value can't be 0. Because if you think about how a fraction becomes 0, you always have 0 on top. So 0 divided by 2, for example, is 0. Or 0 divided by 5 is 0. Or 0 divided by 7 is 0. And they all have 0 on the top. Well, in this case, we have 3 on top. There's not an x. There's no way to make it become 0. And so because of that, this is this range value, y value, cannot be 0. And so it can be anything else. So it's anything from negative infinity up to 0 in union with everything from 0 to positive infinity. Now, if you were to look at the graph of this one, this is an odd looking graph, but it kind of looks like this. And there's what we call a vertical asymptote. Oh, hang on. I put those in the wrong place. It's not at 0. It's at, we said it couldn't be 2. So let me go back and fix that for you. Alright, so our graph looks like this, where there's a vertical asymptote at positive 2. And again, this is just a sketch. Basically what a vertical asymptote is an imaginary line that does not have a point on the graph. So if you notice, as this graph goes from the left towards this 2, it gets closer and closer and closer to this 2, and then as it gets closer to it, it turns and it runs down, getting really close to it without ever actually touching it. On the other side of that asymptote, here at the top, it's really, really close to it, and as it gets further away from it, it begins to run more to your right and never does touch that 2. In this case, there's also, though, a horizontal asymptote at 0 because our y value can't be 0. And so if you think about it from the bottom to the top, as it comes from the bottom up, it gets closer and closer to 0, and then it turns and it runs left. And then on the other side of 0, it's really close to it down here on the right, and then as it gets closer, it runs more up. And so when you see that graph, it should make sense, again, from domain and range, that the domain is from negative infinity up to 2, and everything from 2 to positive infinity. So it just skips over that asymptote. And then same thing with the y value, going from the bottom up. It goes up to 0, doesn't touch it. On the other side of 0, it goes from 0 up. And so that one can be sort of confusing. Every one of these that has a fraction with a variable on the bottom is going to be a similar type graph. Okay, so just be aware of that as you're working through some of these. And then our last one is an inequality. And this inequality is never, ever, ever, ever going to be a function. So if it is an inequality, it is not a function. I'll explain why in just a second. We're still going to find domain and range similar to what we would do if it were a function. So domain is what we put in. Well, if you put in a number and you make it negative, well, you can do that to anything, right? You can take the opposite of any number. And so our domain here is all real numbers. And the range value, the y value, is what you're getting out. Well, if I put a number in for x, if I choose the right number for y, I can make this inequality be true. And so I can get any number for y. It also is negative infinity to positive infinity. Now, Somebody may ask the question, well, why is it not a function then? Well, that's a great question. I'll give you a sketch to kind of illustrate this. The graph of this equation, or this inequality, is going to look something like this. But because this value is, or this inequality says y is greater than that negative x, there's actually some shading that happens that's part of the graph above that line. And so when you start thinking about the vertical line test, well, if you draw a vertical line through that graph, well, you're touching a whole bunch of points here at the same time. And so because of that, that x value is repeated. It's not a function. And so that maybe makes some sense for some of you. But you could also think about it this way. If I were to take, let's say, 0, 1, and put that in as a solution for this inequality. Negative 0 is just 0, right? And that is less than 1. So that is a true statement. I could also, though, use 0, 2, and that's a true statement. Because, again, negative 0 is still just 0. That's less than 2. And this also is true, and this also is true, and so on. And you'll notice that all these x values get repeated. It's the same x value. And all of those are solutions to this inequality. And so because of that, you have an x value that's getting repeated. Therefore, it is not a function. Now, I know these 5 examples can be kind of complicated. I know there's probably a lot of questions that you would have. If you've watched through the video and you have questions, again, please email me. If we need to do a Zoom session where I go through this in more detail, let me know.